Hi everyone, Meta has introduced a new model which is large concept model. We are already familiar with the LLM, means the large language model, but Meta is saying that these LCM, means the large concept models, are far more better than the LLM. Okay, why? Let me show you one post. Here you see that this person is the co-founder of Hyperbolic. He is saying that I am more and more confident that tokenization will be gone. Why? So let me show you one tokenization concept, those who don't know. So inside this LLM, if I give any text to this model like GPT-4o, GPT-4o mini, they actually break the whole text into some words, and they find the meaningful words and define that as a token. For example, I have given this whole text or sentence to this model, and they have broken down this whole sentence into some meaningful words and define that as a token, and they have found 11 token. Now for example, this large have a meaning and this language also have a meaning. Okay, now if I modify this large uh, as a TTT. Okay, now if I see here, it got increased from 11 to 14 token. Okay, why? Because they have not found any meaning inside this large TTT. So they have actually broken down these large TTT to this L and this ARGT and this TT and T. Okay, so extra 3 token got increased, right? So it actually depends on the input that you are giving, how it looks like, right? Now what was the problem? So if I show you that this is the post. So human don't think in token. Okay, humans don't think in token. See, if I tell you that what is agentic AI, okay, so your answer should be like agentic AI is like this, and it do this. Okay, it has this much of capability. So your answer is in the form of sentence, not in the form of words. Are you getting it? So you are giving me a outline, like what is agentic AI. You are giving me in the form of short sentence, not in words. So that is he actually telling, and that is Meta also telling that. See, tokens are hard-coded abstraction in LLMs that lead to weird behavior. So LLM can solve PhD level math questions but cannot answer is 9.9 is greater than 9.11. So this is the very important question. We have already seen that many models don't have the capability to give the correct answer that 9.9 is greater than 9.11 or not, right? Why they are not get capable enough to give the correct answer for this simple question, although they are solving the complex PhD level math question. So for this, here you see that Meta is shifting LLMs to LCM, large concept models, and changing next token prediction to next concept prediction. And what is concept? A concept is treated as a sentence representing an abstract idea or action. Okay, so actually they are telling that we will not take this token as a unit to build or to give the output. We'll use the sentence as a unit. Are you getting it? So let me show you in detail. So here you see that the sentence becomes the fundamental building block. Okay, so inside this LCM the sentence becomes the fundamental building block, not the token. So in traditionally what happens that LLM predicts word by word, but here in LCM what they will do, they will predict sentence by sentence. Okay, so what is the problem? Here you see that um, you will get the broader conceptual dimensions. Okay, and sentences are represented points in a continuous spaces. Okay, and what are the advantages that you will get? It will reduce the complexity of long scale generation. So what happens that when you use the LLMs to build or to generate a long form of content, so in that case, uh, a token is generated. After that, the next prediction will be based um, on that token. Okay, so if I generate a summary type of content, then it is okay. But if I generate a long form of content, so in that case it will be very difficult to get the best output, because here you see that this LLM token concept increases the risk of generating coherence errors. Okay, so this is a very much important things. LLM concept or token concept increases the risk of generating coherence error. Okay, so here you see the crucial point is defining a solid and stable semantic space where sentences are not just scattered coordinates but strongly organized nodes with deep meaning. Okay, so that's why they are going for the LCM. So they have also published a research paper. So here you see that in their research paper they are telling the human brain does not operate at the word level only. We usually have a top-down process to solve a complex task or compose a long document. Suppose if anyone tell you that what is agentic AI, okay, or what is machine learning, then you first give him the outline. Okay, can't give him, or you generally don't give him the details line by line procedure, like what is the advantage, what is the disadvantage, what is the thing that you can do with machine learning. Okay, you don't generally give someone like this way. You give a outline that this is machine learning and this is agentic AI, right? So this is called a top down approach, and human always think like that. So here you see, we first plan at a higher level, the overall structure, okay, and then step by step add details at lower level of abstraction. This is called human thinking. And as we are building some LLM models, okay, or we are building some machine learning models. So in that case, we should build that model as a human thinker, okay, because we are making these models so much powerful so that they can generate the idea, or they can give the ideas, or they can actually write anything, right? So we are making the machines as powerful as human. So in that case it is important to make the machine also think like the human, right? So here you can see, one may argue that LLMs are implicitly learning a hierarchical representation, but stipulate the models with an explicit hierarchical architecture are better suited to create coherent long-form output. Okay. And next, here you see that they have given a cool example. If you read this, imagine a researcher giving a 15-minute talk. In such a situation, researchers do not usually prepare detailed speeches that I have already told you. So that's what I already told you. That suppose you are a researcher and you got invited from 3 college to give a speech. Okay, so in one college you gave speech in a English language, and in one college you gave speech in a Hindi language. Okay, because there people don't know the English language. Let's say, okay, and in one college, in another college, you gave a speech in Spanish language because people there don't understand the English and Hindi, right? So in 3 colleges, you have given the speech in 3 different languages, but your ultimate outline on the topic will remain same. Just you are changing the language. You are just changing the language, but your ultimate outline of on that topic will remain same. So here they are also telling the same thing, that researchers do not usually prepare detailed speeches by writing out every single word they will pronounce. Instead, they outline a flow of higher level ideas they want to communicate. Should they give the same talk multiple times? The actual words being spoken may differ. The talk could be given in different languages, that I told you, there are 3 different languages. But the flow of higher level abstract ideas will remain same. Outline on that topic will remain same, but the language is changing. Similarly, when writing a research paper or essay on a specific topic, humans usually start by preparing an outline that structures the whole document into a sections, which they then refine iteratively. So when someone tell me that write a essay on this topic, we generally prepare some outlines that what we know on that topic. After that we refine and or we add some examples or to do something later. But first we write the outlines that we already know, right? So humans also detect and remember dependencies between the different parts of a longer document at an abstract level. Now, here you see, keeping track of dependencies means we need to provide result for each of the experiment mentioned in the introduction. Finally, when processing and analyzing information, humans rarely consider every single word in a large document. Instead, we use a hierarchical approach, means the top-down approach. We remember which part of a long document we should search to find a specific piece of information. So this is the thing. And another thing that I want to mention you. So they have introduced two things. One is a one tower and two tower concept in this LCM procedure. Okay. So one tower diffusion LCM means, here you see that there it consists of a single transformer backbone which task is to predict the clean next embedding, and here it will actually do the things for a low complex task. Okay. And for the two tower diffusion, it will do the tasks for the high level complex task. Okay. It will do the high level complex tasks, and they will use this contextualizer, takes as an input the context vectors, and then here you see that they will do the things. Okay. So you please read the this whole this research paper. You will get the idea that what actually they are they want to do. Okay. And there is a diagram that let me show you. So there is a pink color and there is a this blue color also. Okay. So this blue color text is the outline. Okay. So here you see the follow my cursor. This blue line text, like, because he was not very athletic, team could not join teams to improve. And after that, so he decided to train on his own. After that, he decided to train on his own instead. Okay. So these are the outline. Okay. Now on the left hand side, this is the very clear picture, means the detail by detail explanation. Okay. So why he actually he was out of the team, and what was happened. Okay. Why team could not join the teams. This is the things. Okay. So here you see that this is the thing that, like, we are giving the input, and it is converting that input to concepts, which is the building block of LCM. Remember this thing, building block of LCM is the concept, and concept is nothing but a sentence. Okay. And in LLM we use token. Token was like a word, and in LCM we are using concept as a building block, and building block are the sentence. Okay. And here we are providing this concept to this large concept model, and it is giving us the output, concept decoder, encoder decoder concept. Okay. So if you found this video helpful, guys, please make sure to like this video. And if you want to get this type of videos more, and also yesterday I published a video on this DeepSeek client plus DeepSeek integration, Gemini coder, and this Rook client, Ada plus Gemini. If you want to get this type of videos more also, don't forget to subscribe this channel. See you in the next video. Thanks for watching. And if you found this helpful, please make sure to like this video, guys. Okay.